All right, let's start. So hi guys, this is Chris again. I'm gonna be the host for today's the workshop sessions. Today's workshop is topic is curing chain data from with blockchain, and speakers we are very happy to have Bram, which is SC developers, to join us again for the third time. So won't speak too much from the beginning. I will let Bram to take the stage and start from here. So Bram, feel free to start when you're ready.
Okay, thank you for the introduction. Okay, so let's quickly recap what we did do in the past two sessions. For the people that are just joining us, we created a DApp. Let me get that URL. So we created a very simple basic minting DApp. We can mint an NFT, we give it a name, and we give it an image hash. That's basically all it does. From there, the last week session, we basically continued to connect a very simple UI to it. Let me quickly start this one. Oh, okay, let's get this annoying thing away. Okay, so I'm starting up our project from last week. Almost started. So what did we do last week? We created a connect or wallet button. Let me quickly log in. So we added a connect or wallet button. We displayed some data from signer. We created a create NFT button. So what we're gonna do today is we basically, you see here, we get a pop-up to mint the NFT. We're not gonna do that for now. What we're gonna do today is we're gonna query all this data we are storing on the blockchain, because it's very nice that we can connect to the blockchain. It's very nice that we are able to basically use WaveSigner. But of course, we also want to read our data from the blockchain. So how do we start? I usually start by taking the DApp and then going to Waves Explorer. So if we go look Waves Explorer, we take the DApp, and then we basically see all our invocations. So what is the next step? We take our invocation and we basically look what is happening. So here we see that we have like a transfer of an NFT, we have a payment, and we have an issue of an NFT. We also see there are like three kinds of data transactions basically. It's not very clear to read it like this, so we will open it and we can see it here a bit more clear. Here, state changes data, and we have basically our data that has appeared in our account. So we see one NFT creates or edits or updates three fields in our case. If you remember, the first field is newly created, the second field is newly created, and the third field is this is the third field. In the third field, we are updating every NFT that we are minting one. Like you see, 8 NFTs should be minted at this moment. So this is the data we will be working with. Now, to see an overview of all this data, we can go to the top and we can look at data. We can say load all, and we basically see all the data stored in the DApp. For now, it's not too much data yet because only 8 NFTs, so it's like 16 keys, something like that. And you can here then basically see the data. But of course, this is not very user-friendly to use in a DApp, or almost impossible to use in a DApp. So we are going to interact with our node. We have probably used this node already in the past. So when we see it's just a Swagger interface, it's very easy to try it out the first time. We are currently working with data, so we're gonna look for something with data. So we see this is address topic, alias, assets, blockchain, blocks. And then if we go down, even more down, where is he? Wait, blockchain, no. Oh, address. It's an address. So then we see there are different calls based with data. So there is a get call, there is a post call, and another get call. So we have one get call that is data by keys or regex expression, one call that does exact match, so no regex, and then we have for like multiple keys that we can read out the data. So in our case, what we're going to probably be using is the regex expression. So if we see, we can copy paste our tab address like this. So what is the most easy regex expression? It's just a dot and a star. That will basically match everything. With the DAP, when there is a lot of data, this might give some problems in the browser, but for now we have just very limited data, so we can query it. We now get an example URL, and we do see the output of all the data fields that are available. So let's say we are not interested in all the data, we just want all the unique names. So what do? We extend our regex and we say name, because what can we see? All our keys have basically something underscore name. Something underscore name. So that way we will get all the names from the NFTs. You see? So this is basically how you do the basics data querying on the Waves blockchain. The better you match your data, the smaller the data that you will get back, like the total data will be smaller, and therefore you need to do less filtering in the UI. So what are we going to do today? I prepared it already a little bit. So we're gonna add a new list. We're gonna add a new button. We're gonna add a new list with all the names displayed. And then when behind every name, we basically want a button to get the EPFS link back. You might notice some data is a bit like wrong because we created some NFTs with a wrong EPFS link or a non-existing EPFS link. Like here, 4 we picked. 2 times we picked 4, so that is kind of bad, but the other ones should be working for the link composition. So then we will be heading over to our code. Like you can see, we have our login button. We display the logged in user. We have our mint button, create NFT. That's all from last week. We have our signer integrated. We picked the provider keeper. We have our mint DAP already as a variable. We have our login function and onze mint function. So what do we want to do now? We basically want to go and query data. Like I said, we need something to trigger this event. You can do it on load, but let's just make it user triggerable. So what will we be doing? We create a button again. These Q buttons and basically Quasar components that is like framework depending. So that will be like unique for each framework that you are using. Then we will create a method, load all names, something like that. So when we hit that button, we want to load all the names. Load all the names. If we now go loop to a browser, here, we basically see load all the names. Obviously, it's not doing anything yet. because, well, it's not connected with any useful method. So to connect it with a useful method, we need to create one. How are we going to call it? Let us see. Load all names. So there we go. Load all names. Obviously, we also need to create this method still. So let's just say we're gonna write it here. Load all names. It's already proposing it to me like this. For now, as a first step, we just add an alert. Say test. Wait, what is he complaining? Missing semicolon. Oh, we forgot the function. So function load all names. So now when we hit the button, here, load all the names, you see it basically says test. Obviously, that's kind of useless in our use case. So what do we want here? We want to query all the names and we want to display all that data. So we are going to create a reference variable. It's still uncommented here, NFTs. And we're gonna put a value in it. NFTs.value is, for now, let's put an empty array. Then we need to return this NFTs. Okay, and then of course we should create some kind of loop to loop through our NFTs. That comment is a bit in my way. Okay, so we're just gonna create a very simple loop for NFT and NFTs. Okay, we still need to add a key. So that's key is .key. Why will it be NFT.key? Because from the data endpoint, we will be getting back key and values. We can also do it, yes, let's use the key for the unique way and then okay. So then we gonna finish our div. Okay. Why is he complaining? Unexpected. Fee for NFT and NFTs. Oh, I already see it. We forgot this. Okay, so now basically we have put up our for, but we don't print any data yet. So let's have a first print of data and we say, let's just print NFT. At least that way we will be sure when our data loading works. So what will we now need to do? We will need to create a method to query this data from the blockchain because it's not gonna magically appear. So we will create basically an Axios object, constant waves node. You can see I already prepared it a bit, but let's just go over it together, create, and then we have the constructor and we say the base URL. So what are we saying basically? Our base URL for this Axios object is basically this node. So every time we query Waves node with an URL, we will go through this node. You can put your own node there. That's obviously advised for uptime and all that kind of stuff. So we defined this one, that comments can go. So now we have a node object. Obviously, the node object in itself won't be magically making the data appear. So what do we need then? We do need some data calling. So we will create a function. We say let's get data. We say it needs an address. And basically for now, let's take an address. Okay, so we say like this. What we're gonna do then is define a variable. So constant data, because we will be getting this data back, is await. So we will query our node URL dot get data dot get. Yes, like this. You see, he's complaining because it's an await. So what do we need to add? We add this async. Okay, so now we need to define what URL are we going to query. Let's for now take the hard-coded URL. So like you can see, here we have the hard-coded URL. Are we going to query on IPFS hash? No, let's query on the name because that's more human readable. So we can copy paste this URL. What is very good advice is always try your API calls in the Swagger. Then you have like one less layer to debug in case something goes wrong. So when we see then, we have already the base URL, so we can remove this whole first part. We just keep the unique stuff like this. And we now basically say, okay, we have a variable data. We will do this get call on top. But obviously our method is not returning any data yet. But for demo purpose, let's say console.log and let's print data. It's always a good idea to do it in like steps. That way you're always sure that stuff is working or like that step by step is working. Address for now is not yet needed. We just hard coded it, so let's just remove it for now. And then we can basically call this method. So we say get data like this. We need to add await. But it's void, so we say void because it's an await here. Okay, it's not returning data, so we need this void type. So normally when we would go now to our app, let me reload that one. Why is he not happy? Let's see. Console Axios is not defined. Okay, we obviously need to import Axios. Yes. Okay, let's reload it once again. Okay, now you see it loads. Let's click this button. Oh, and we see that there is an error popping up. Our address seem to go wrong, so it's not working yet. Let us look into the code. So we have await waves nodes dot get. See, so yes, that should be fine. Why is he not happy at this stage? Let us see. URL. Create this object. Let's see here. Create actions defaults. Why is he not very happy? Constant waves node Axios create. That should be fine. Am I doing something wrong here? That is probably not the issue. No, for what reason does he wants to go there? Let us try this for now. Oh. Something goes wrong with the base URL apparently. But like you can see, we have now our data ready. So we get 5 NFTs, 6 NFTs back, and we have this data. So when we now want to return this data so we can use it, we just add the return statement, return data. So then our NFTs value, it's not going to be void anymore. So what we can now do is here get this. And obviously it's gonna need to be an await. And this needs to become an async one. Okay, so we have now load all names. Let us go look here at the data. So we have this method, we have NFTs, okay, should be good. Okay, so like you can see, we are now querying our data. Currently, it's obviously very, very ugly. So let's format it with like name and then asset ID, something like that. So we have now this whole NFT object, but basically, where is the asset ID included? It's in the key. So if we then say we want to have the key, so and we have the name, and that will then be from the value. There is going to be something wrong still with the key, but I'm first going to do this as a middle step. So you see, the key is still like very unparsed. We need to remove the last part, basically. So how can we do that? We just say we're gonna split. Most of you developers probably know this already. And we're gonna take the first part from the array. We are always sure about how our keys are since they are coming from our DApp. And because of that, we can be sure that they should be correct. So we see now asset ID name. I'm going to add a BR so it's a bit more clear. And then here something like this with another BR. We're not going to focus on a very beautiful UI. We are mainly focusing on querying the data. So like you can see, we now queried the blockchain data, the asset ID, and the name. So what is missing from our data? Like you can see, we also have this IPFS hash. So we're gonna change this. What we also gonna do is, we don't like hard-coded URLs. Imagine that you need environment variables or something like that. So we're gonna adopt this method. We're gonna make the address flexible now at this stage. So we say address. Oh, I need to use this dollar sign. Okay, and we're gonna say we need to get an address. Oh, so our get data function will also need to get an address, and that's our min.dop. We have this min.dop from our first session for the people that don't remember it. Let's see if we broke something again. No, still working very good, very smoothly. So what's next then? We made this flexible, and now we basically want to query the hash from each NFT. We could be doing that with a button. Let's just do it with a button again. So we can here append below this BR. Okay, let's here create a Q button. Okay, like this, Q button. And we gonna say load. Oh, that's a typo. Load IPFS data, something like that. We're gonna add a click event. Oh, not a can play. A click event, and we say load IPFS hash. We do it like this. And we also gonna give the hash that we want to load with it. This method not gonna, we need to have single quotes here. Otherwise it will be conflicting with our double quotes. So obviously this function again doesn't exist. We're gonna create it now. Okay, we say here, load IPFS hash, we scroll a bit up. So here, load IPFS hash. We would be getting a asset ID like this. And function before it. Okay. Obviously, we do know how our key is going to be looking like, because we do know that we always have asset ID underscore IPFS. So that means we could, instead using the regex, we could be using the data by key call. So if we would put in an exact key, it will return it. Okay, here, that's the exact key. Our script. So this is our script. Let's execute it, and you will see we will be getting back the data. If we would be doing something like this, we won't be getting the data because it says no data for this key. But that means we can create a method that returns the exact key. Let's rename this tool get data regex, and then we also need to rename this one, obviously. Okay, and then let's say an async function get data key. We're gonna add the address dynamically at the same time, and we're gonna add the key that needs to be dynamic. We can do the same again. We can basically copy paste this for now. So we copy paste it, and we're gonna adapt the URL. So like you see, the URL is something like this. So, okay, here we need to have the address, and here at this place, we're gonna need to have our exact key match. And now we're gonna query the data address exact key match, we return it again, and now let's use this method here. Constant IPFS data is data t. We do need two fixed variables. We know the min top, but we don't have the key composed yet. So let's first do that. Constant key equals our asset ID plus we know it always is an underscore IPFS. IPFS, right? Double check it. Yes, it's IPFS. Always make sure it's double checked. It's case sensitive, so it's very important that you don't have like camel casing mixed up or something like that. So now we do know our key, and since we know our key, we can now add it here. So our IPFS data will be queried through this new method with variable address and key. It doesn't do anything yet, so let's say we're gonna throw an alert with IPFS data. Let's see what result it will be giving. We already connected that one, I believe. So let's test it. Load IPFS data. You see at this stage is an object promise. Where was I? Here. So if we go look, why is it an object promise? Because this is basically giving an await back. and we didn't put await here. When we put await here, we will resolve the promise, and so we need to add async here. If we're now going to execute it, we will get a different result. It says still object, object. Why does it say object? Because there is like object data in it, obviously. So how are we going to like figure out what data is inside? To make sure that we have the correct data, we can just do a console log. And you will see there's a console log with the data. Like I said, we have like two that are like kind of ugly, but let's take this one. So we will see now that we have our EPFS hash. You see? So we have EPFS, key, type is string, and value. Or maybe very important to tell, the key types, the type can like have different values. You have, for example, string, you have integer. I will show you Rails docs once again. Like I told in the last sessions, docs.rails.tech is a very good website with a lot of information. So let's look up data entry. So if we look up data entry, okay, we can go to here. So you see there are basically four kinds of data entries: the binary entry, the Boolean entry, the integer entry, and the string entry. So our entries could be anything from those four. But what is important, you do define this in your DAP. So if you in your DAP say or define string entries, you are certain it will be strings. If you say it's an integer entry in your DAP when you're coding it, you are sure it will be an integer. In our case, we only used, we did also use an integer entry here. We can use that one later if we still have some time. But for now, we have always used string entries. So what if we look back at our data, what do we want? We want our EPFS hash. So we know that this is the value. Now let's compose a nice EPFS string from it so that we can open it in one go and show that it is working. You could also, for example, load this data, display it as an image in your HTML page. Basically, what you can do with it is unlimited. But like I said, we are just focusing on query the data from the blockchain. So if we then now go look here, we do load all the names, we see all our images, and then let's say load EPFS data. We get the link. Let's copy paste it and let's go to it. And there we go. The famous pictures from our first session is appearing. So you see, we have now a full minimal working flow. You basically created a DApp, then can mint an NFT. After you could mint the NFT, we connected signer and keeper with our application, like with our UI application. Then we also did an invoke of a transaction. And now we have the final step of querying the data from the blockchain. So let's do one more thing before we round up this tutorial. Let's display on top the amount of NFTs that are minted. So let's say, okay, let's create a ref. Basically, what a ref does is like dynamically tell the HTML aspect, hey, I'm updated, so please take the new value. Again, this is framework specific. Every framework works in its own way with that one. So we're gonna display this amount minted. We need to return it again. So amount minted, and let's just put it somewhere on our page. So let's put it here. If okay, Total NFTs minted. Amount minted. No, nothing is going to happen. It will be 0. Even if we click load all the names, it will be totally 0. Let's quickly add this below it to make it a bit more clear. So like it stays 0. Now we want to update it. You probably already noticed it. This key is like a fixed key. So we always know what key we will be getting. So we don't need to compose a key. We don't need to use a regex. We can just use the exact key. Total minted key. We can define this one here. So let's just load the data here. So here constant total key is the string. So how did we call it again? Amount minted. So with the amount minted dot value, that's again something Quasar and ref specific. It will depend on your framework. So we can now say get data by key. We say we want to have the min top, and we say we want to have the total key. This will give some issue, but let's look at the result first. So you see, when we click now load all data, it will basically return the whole object. And like I told you before, we can have different types of data. So this is an integer, but again, like with the other examples, we just need to get that data filtered out. So we have here the amount value. Let's put it in a temporary variable. Const total key data is like this. And then we can say here total key data punt value should be or should do the job. And there we go. We now see that we have like 8 NFTs minted. Actually, that's all there is about like querying the data from the blockchain. For the people that are interested, this Swagger API has a whole lot of useful information. You can query basically anything from it. So the addresses, the blockchain, the assets. You can even look at the NFTs. Let's just look at all the NFTs. So when we say connect our wallet, let's grab this wallet, for example. What you can do, if you want to create a wallet that displays all the NFTs, you just display it. You say how many maximum you want to have returned, let's say 15, and let's execute it. So you see, there is basically, for example, this call, you would be getting back the NFT name, the description. You see an NFT always has 0 decimals and is never reissuable. So you always see quantity 1. What else might be interesting? The leasing info, a bit less interesting. Transactions info might be very, very interesting. But the broadcasting you will usually do through WaveSigner. So I guess that concludes our last tutorial. And so now we basically went through the whole stack from write to UI. So yeah, that was my last tutorial for now. I hope you enjoyed it. And let's see, where is Chris?
Thank you.
But there is Chris.
Yeah, thank you. Thank you very much, Bram, for another very meaningful and useful workshop for our developer communities. I think I haven't seen any questions from the audience. But I guess I just want to know a bit more information about like the next steps of the Waves hackathon, because the Waves hackathon gonna end in the March of 23rd. So maybe after the hackathon, is there any exciting news that you guys want to share with other with global communities for the can be future roadmap or any of news or things that you guys want to share?
Well, I guess there's a lot of exciting things that are going to be happening in like the Waves ecosystem in general. If you have been following Sasha, for example, he's mentioning Waves 2.0. So like there will be a total different change. And like Waves will be very great this year. They will fix a lot of things. They will improve a lot of things. So I definitely think that it is worthwhile in general to follow like the Waves blockchain and the Waves project. Um, and for sure, if you are a developer, make sure to check it out and to try out some stuff because you have seen it's all very easy, very convenient. So don't miss the opportunities.
Got it. Got it. Cool. That sounds definitely very exciting. Looking forward for all of those in this year's. And I guess we can end it up here. For all the audience, as I mentioned, the Waves Hackathon is still going on. It's gonna end in March of 23rd. So if you are one of the developers that want to build something interesting and innovative based on Waves blockchain, I highly suggest you to seize this chance to register your project profile and submit to the Hacks platform. It's going to be a great chance. Waves Labs provides tons of the support and resources for brilliant teams who emerge from this hackathon. And also, I think feel free to review all of our workshops that we have hosted before for you guys. You can find those through our YouTube channels and also Waves YouTube channel. Yeah, uh, and I think that's pretty much it. Thanks again, Bram, for joining us and provide a very great workshops again. Um, and hope all of you guys could doing great. And also, Bram, I think this is like your very last workshop, but it's great
Yes.
to meet you and work with you on this series of the workshop. And yeah, if audience, if you haven't joined us on YouTube on our social media channels, please feel free to do that so you won't miss out any of the great workshop like today's in the future. So yeah, that's it. Thank you guys. Thank you guys again very much for joining us. Hope you guys can all doing great. Bye.
Bye.
Thanks, Bram.